let's get a fresh paper. Okay, let's say you are filling your tires. So let's say you have got these 17-inch tires. (17 inches). So let's say the outer diameter is 17 inches and the inner diameter is 8 inches. And let's say you, let's give the dimension of the thickness. Let's say it's thick tires, 10 inches. It's pretty wide. Okay, so now let's say you want to fill it to a pressure. The typical pressure that most tires you run at is 40 psi, 35 to 40. You know, you don't want to fill it too much more than 40. But that is actually the gauge pressure, right? In other words, that's the difference of the pressure inside the tire and the outside. That's not the absolute. So when the tire manufacturer tells you pump up the tire to 40, they're actually saying pump it 40 larger than atmospheric, you see? So the absolute pressure, so this is called gauge pressure. You guys have heard of that term? Which means it's that difference of the pressure inside something and out in the atmosphere. So then the absolute pressure would be what? Would be 40 plus 14.7. 54.7 psi. Right? So now the question can be, if the temperature of inside of the tire is 20 Celsius and outside is 20, and let's say the inside is 20, calculate the absolute pressure, calculate how many moles of air you need to have in there. The number of moles of air. It's kind of a simple example, but it's nice to illustrate on a tire example, because that's like an everyday example. You go, you fill out the tires with some air, right? So we're just going to do PV is nRT, right? We know this is 54.7 psi. So how can I convert that to cubic meters? I'm going to say 14.7 psi is 101.3 kilopascals. So in other words, remember 1 atmosphere was 14.7 psi. I should say the 3.325 is better. In other words, remember 1 atmosphere was 14.7, but it's also 101.325 kilopascal. So they're equivalent. So that's how you can translate from your absolute pressure in psi to kilopascal units.
Why did you add 14.7 and 40?
Excuse me? Why did I add? Because this was the gauge pressure. When you say your tire's pressure is 40, it's not the absolute pressure.
So we add 14.7.
You're 40 larger than, yeah, because what's happening is from the outside, the air pressure 14.7 pushing in. If your tire is like flat, 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 imagine a tire that is as flat as you can imagine, then the pressure inside is still 14.7 pushing out. And that's like a really dead flat tire, right? in order for you to get a pressure less than 14.7, you would actually have to have a vacuum pump to go in and vacuum the air out to lower it below 14.7. You see? So the flattest bowl you can imagine, the pressure inside is still 14.7. You see, it's not zero. You see what I mean? No?
Yes, thank you.
Oh, okay. Okay, so now I'm converting it to pascals. Now the volume. Oh, how do we calculate the volume of this? So it's pi r2 squared minus pi r1 squared times the thickness, right? So pi 17 inches squared minus 8 squared, 8 inches squared, times the thickness this way is 10 inches, right? But then I want to convert from that to meters cubed, because this is going to be inches cubed, right? So how do I convert that? 1 inch is 2.54 centimeters. Then I cube that. So because the reason I gave in inches is that's how we usually say. I'm buying a 17-inch tire or a 19-inch tire, we say in inches. So then we convert that, we get the volume, multiply by the width of the tire. Then 1 inch is 2.54 centimeters, but then you got to cube it. Then you got to say 100 centimeters is 1 meter, and then you got to cube that. Okay, now all this is on the left side. You see? And then that's equal to the number of moles of air times the gas constant times the temperature, which is 20 Celsius, but you got to convert to Kelvin, right? 293.15. So even though it's an easy problem, but there's still stuff to maneuver your way around, you know? Converting to pascals, getting the volume, converting to cubic meters, then using that. Okay, now we're ready to calculate how many moles. So that'll be the typical number of moles of air inside of a typical tire.
Why are we cubing 2.54 over
Yeah,
1?
when you do unit conversions, if you have to get rid of inches cubed, then you go from inches to centimeters. You have to cube it because you see inches times inches squared. It's inches cubed. So I have to cube the inches here to get rid of it. Because this is units of volume. You see what I mean?
Yeah. Where did 10 inches come from, though?
Huh?
Where did 10 inches come from?
Oh, I just made it up. I said assume that the width of the tire this way is 10 inches. Okay. It's a cylindrical tire. Okay, let's put all this in. 54.7 times 101.325 divided by 14.7 times pi times parentheses 17 squared minus 64 close parentheses equals times 10 times 2.54 cubed equals divided by 100,000. That's the 100 cubed. Okay, so 43.6737
I think
No, it should be. That's too small. Hold on.
yeah, because it's kilopascal.
Ah, I see. I made the mistake that I shouldn't. Yeah, 10 to the third. Yeah. Earlier in that other example, the kilo canceled out. I didn't need to worry about it. Yeah.
Yeah, the number's correct. It's just multiply.
Times 1,000. Because I thought, oh, that's too little. How could it be? Okay, so 117.919 moles. Okay, so if the problem wanted me to calculate the number of moles of air in the tire, I could stop there. But if they wanted to calculate the mass of the air in the tire, what would I do? Then I would look at the molar mass of air. So air weighs, well, not, I shouldn't say weighs, but has a mass of 28.97 gram per mole. Because it's mainly what? Nitrogen, right? Nitrogen is N2. Yeah, nitrogen dominates our air. Nitrogen has a mass of 14 grams per mole, and N2 is 28 grams per mole. Yep, that makes sense. And then some of it is oxygen, which is O2, and that's what? 32 grams per mole, right?
Yes.
So if you think about it, this is sort of the average of N2 and O2, which is slightly more than 28. Yep, makes sense. Okay, so then if I want to calculate, I say 1 mole has mass of 28.97. Let's see if the numbers make sense. Times 28.97. Okay, so the mass of the air, 519.1. Wow. So that means a typical tire has a half a kilogram of air. Right, that's about a 0.5 kilogram. Which is, since 1 kilogram is 2.2 pounds, that's about 1.1. That's funny. So you have about 1 pound of air in each tire.